In part D of example 1.17, we have another equation provided. This is g of x. Let's take a look at the operations we see within the equation. We have a subtraction, we have a square, and this time there is a square root. Now, out of those three operations, only the square root has any kind of restriction. We talked about this in part B of example 1.17. So the concern here is that we do not want any negative numbers to appear underneath that radical. So what we do algebraically is we take the expression 9 minus x squared and we say, let's have it be greater than or equal to 0. And this will allow us to find precisely what the domain needs to be for this equation. Now, to solve this, since it is an inequality, I still want to try to get the x over to one side. So I'm going to have 9 is greater than or equal to x squared. Now, normally, to finish solving for x, I would take the square root of both sides. However, that is not allowed when you're dealing with an inequality. The rules that all of you are familiar with for solving equations work for equality. Equality meaning equal signs. Some of those rules will work for inequalities, but not all of them do. So we have to be extra special careful when working with an inequality. Now, as it turns out, this type of inequality here is known as a compound statement, which means I can break it down into two simple statements. Here's what I mean. I can take the greater than and I can make that a simple statement. 9 is greater than x squared. Or 9 could be equal to x squared. So I'm able to get both of those statements from the greater than or equal to symbol. Now, the benefit to doing it like this is that now I have an equation with an equality. So I can go through on this and take the square root of both sides. On the right-hand side, I end up with just x. On the left-hand side, I should have 3. However, you are not allowed to take the square root of both sides for free. There is a cost. And the cost is that you should be identifying two answers, positive 3 and negative 3. Now, what this means from a number line perspective is that we have two boundaries in this domain. Negative 3 is going to be a closed boundary, and positive 3 is going to be a closed boundary. These are not restrictions. We only do restrictions when we're talking about division by 0. Here we're talking about dealing with the square root. So those are going to be a part of our domain. Now, these are going to function as boundaries here. They're going to serve as boundaries. So there are 3 different sections. Section 1, Section 2, Section 3. We have to select a value from each one of these sections, and we have to test the inequality. So let me show you what that looks like. So over here on the left section, let's pick, let's say, negative 5, for example. So if I let x be equal to negative 5, then this inequality is going to say 9 is greater than negative 5 squared, which means 9 is greater than 25. And that is false. So that means that the section number 1 that we had over here, section number 1, is not going to be included in our domain. You would need to do this for section 2 as well as for section 3. That's what the boundaries do for us. The boundaries split us up into these sections. So now let's pick something in section 2. To me, the easiest choice here is to pick 0. So I'll move over here to the side a little bit. If I let x be equal to 0, then my inequality will say 9 is greater than 0 squared, which means 9 is greater than 0. And that is a true statement. So every single number in section number 2 is going to behave just like 0. So I'm going to connect my two boundaries in between -3 and 3. Now let's check one final section. We'll check section 3. To check section 3, I'm just going to go 1 unit to the right. I'm going to go to 4. So if I let x be equal to 4, then we'll have the statement 9 is greater than 4 squared, which says 9 is greater than 16. Unfortunately, that is a false statement. So I will not be needing section 3. The only section that I need is section 2. So to summarize, the domain of G is equal to the closed bounded interval -3 to +3. Now let's take that domain and let's make our function definition. G has a domain from -3 to 3. All of those values will map to a real number given by g of x is equal to the square root of 9 minus x squared. And there's our function definition for part D.